Right. All right. We're just right at 4 o'clock. Thank you, everyone, for joining us. I am Liz Perry, Kirk Canyon's president, hailing from my office here on our campus in Cortez, Colorado. As we get started, I'd like to begin, as we do, with our land acknowledgement. Crook Canyon acknowledges the Pueblo, Ute, Paiute, Dene, and Jicarilla Apache people on whose traditional homelands our campus sits. We acknowledge the first people of this landscape, the human people, the animal people, plant people, water people, and rock people. We ask permission of the first people to enter this space and make a promise that our words, deeds, thoughts, and actions will be honorable to them. Our work is not possible without Indigenous people in the past, present, and future, and we respectfully recognize and honor ancestral and descendant Indigenous communities for their contributions to all humankind. We are grateful to all Indigenous people and support the preservation and protection of cultural traditions, ancestral connections, and sacred lands. If you are joining us on Zoom, as always, if you put your questions in the Q&A, we will make every effort to get to them, no matter when you enter them during the talk. We will also check the chat, but it's always safest to put your question in the Q&A. If Zoom gives you a headache, we are live streaming on Facebook, and you can also come back later and see this webinar and others on our YouTube channel. If you have not subscribed, please do so. We have some wonderful talks coming up in the next 2 weeks. Next week, November 7th, we have Reconnecting and Relearning Culture, Language, and History through the Native Teen Guide in Training program with Colleen Cooley. In the week after that, Intersecting Community-Based Participatory Research, Native Nation Building, and Community Gardens with Matthew Kirk Tafoya on November 14th. We are skipping Halloween, so there will not be a webinar on October 31st. Just as always, a huge thank you. This is an entirely free webinar series, and so many of you donate anyway. Every time you watch a webinar, we notice you every time, and the series is only possible because of your donations. So thank you, thank you, thank you for your support of this webinar series and of all of our programs. We are a nonprofit, and we are almost entirely supported through your philanthropy. So thank you to everyone. Without further ado, I am very excited to introduce Dr. Lori Barkwill Love, who is a Senior Project Director at Statistical Research in Tucson, Arizona, and a Research Associate with the University of Texas at San Antonio. She earned her PhD in anthropology with a focus in archaeology from the University of Texas at San Antonio in May of 2020. She's conducted archaeological research throughout the Southwest, Arizona, New Mexico, and Texas. Her research interests include village formation, transition to agriculture, ceramic analysis, radiocarbon dating, and Bayesian chronological modeling. She's published chapters in edited volumes and articles in American Antiquity, Kiva, and the Caddo Journal. Thank you so much for joining us, Dr. Love.
Well, thank you for having me. Should I share my screen now?
Yeah, absolutely.
Are we good?
Yep, looks perfect. Thank you.
Okay. Well, thank you. So today I'm going to talk about my research on modeling early maize in the North American Southwest. When maize arrived in the Southwest has been a major research focus for archaeologists. In fact, Steve Lexon has referred to it as the Southwest archaeologist holy grail. It is something that many archaeologists seek, is to pinpoint that date when maize first made it to the Southwest. So why is this so important? Well, it's because maize is at the center of our understanding of the transition between foraging and farming. However, it's important to stress that the initial adoption of maize really did not translate into immediate intensification and dependence on agriculture. In fact, throughout this presentation, when I'm talking about introduction of maize, the dispersal of maize, the spread of maize, or the use of maize, I'm really talking about just that. And I'm not implying any sort of modes of subsistence. Because the transition from foraging to farming in the Southwest was a very complex and sort of regionally diverse. But if we have a really good understanding of the timing of that initial introduction, the timing of the spread of maize, how quickly it spread and when it spread, and the intensity of use, it would contribute to our understanding of this important topic. So first, I thought I'd start with just a little bit of background. So maize was not domesticated in the Southwest. It was domesticated in Mexico from an annual wild grass called teosinte, and it was believed to be domesticated in the Balsa River Valley region of Mexico some 9,000 years ago. Now, some researchers have done studies using phytoliths and starch analyses, and they suggest that probably the earliest use of this early domesticated maize in Mexico was around 8,700 years ago. However, one of the earliest radiocarbon dates we have on this domesticated maize from Mexico dates to about 4350 to 4170 calibrated BC at a 95% probability. However, once it was domesticated in Mexico, it spread and made its way into the Southwest. And as I said, so, when maize first arrived in the Southwest has just been a really important topic in Southwest archaeology. And over the estimated arrival date has changed dramatically over the decades. And these date estimates are often controversial and hotly debated. So in the early 20th century, researchers had a really sort of late introduction for maize into the Southwest, maybe between AD 300 and 500. But in the 1960s, we see a swing to a much earlier date of around 3000 BC. But then in the 1980s, it sort of shifts back a little bit and suggests that maize really did not get into the Southwest until around 1000 BC. Now, today, the estimates for the initial appearance of maize in the Southwest is somewhere between 2500 and 2100 BC. Although dates, some early dates from Las Capas, a site in the Tucson Basin, could push that date back to about 3500 BC, although some of those early dates are questionable by some. Now, the introduction of maize was actually not my holy grail. It wasn't an area, I mean, it was an area of interest, but just sort of a passing interest, something I had never really planned to get involved in. But it was a topic that sort of I stumbled into during my dissertation research. So my dissertation research focused on the Mogollon early pit house period. And specifically, I was looking at whether these early pit house sites could be considered villages. And to that end, I was getting new radiocarbon dates on some of these early pit house sites. And one of these sites was SU or SHU, depending on your preference. Now, SU or SHU was excavated by Paul Martin in the 1930s and 40s, and then again in the 1980s through a University of New Mexico field school led by Chip Wills. And I had access to the material from the New Mexico field school. And I found these, actually they were labeled corn cupules from what feature 6, which was believed to be an external roasting pit at SU. I sent the samples to Karen Adams for identification, and it was identified as a charred maize cob fragment. And I sent it into the University of Arizona AMS lab for a radiocarbon date, fully expecting that I would get back an early pit house date, somewhere between AD 200 and 500. but that's not what I got. The date I got back on this little maize cob was a radiocarbon age of 3,660 plus or minus 24. Much earlier than I had expected. So that calibrates to about 2140 to 1950 calibrated BC at a 95% probability level. So I'm like, okay, can you get this early maize at this site? And I started asking around and asking people, so would it be possible for me to get this early of maize at SU or SHU? And the response I got was pretty much the same. It would always started off with, wow, that's really great. But you know, Bat Cave or Las Capas or the old corn site are older. Now, as I said, trying to find the introduction of maize was not really my goal here, but it really got me thinking, so how does this little maize cob fit into the broader context of early maize in the Southwest? Now, we did get a second date from a maize cob fragment from this exact same roasting pit feature, and it came back with an identical date. Therefore, this was a valid date. So in going to my research, I started with the Bat Cave site because it is also located in the Mogollon Highlands, relatively close to the SU or SHU site. And even though the radiocarbon date, the earliest radiocarbon date on maize from Bat Cave, which has a radiocarbon age of 3740 plus or minus 70, which dates to about 2440 to 1940 calibrated BC at a 95% probability, may appear older. From a statistical standpoint, the Bat Cave early date and my SU date are of the same age. And so again, trying to really understand the context of these samples, started talking to other folks and telling them, well, you know what, Bat Cave really isn't older. It's the same age. And again, the response I would get with, well, but you can't use that date. It's contaminated. So again, led me down to further investigation. And I was able to get access. I got permission to get access to the University of Arizona Radiocarbon Lab archives, and was able to get copies of the original submission forms from the Bat Cave samples, as well as all of the Radiocarbon Lab pre-treatment notes from these samples. And I found that in the 1980s, there were 8 radiocarbon dates on maize submitted by Richard Ford for radiocarbon dating. Now, on the forms, 2 of these maize samples were listed as possibly covered in shellac, and 2 of the samples, one of which was our early maize date, 4187, was listed as covered in shellac. Now, all 4 of these samples were pre-treated the same. At the time, they were pre-treated with hot ethanol and hot water. Today's standards, a common practice for removing shellac from samples would be pre-treatment with hot methanol and hot water. So, but even if this pre-treatment process did not fully remove all of the shellac, the resultant date would actually be younger, not older, given that shellac is a natural resin. So even though there were 4 samples with shellac or potentially shellac, sample 4187 has made its way into sort of archaeological lore as being a contaminated sample. And so we also got to look at the context of when this date was run. So in the 1980s, and as in this slide I showed earlier, the general paradigm for the introduction of maize into the Southwest was that maize did not arrive until around 1000 BC. So this Bat Cave date, at which, calibrated coming about what 2400 to 2000 BC, really just did not fit within that current paradigm. And therefore, it was easily dismissed as contaminated. And this is not uncommon. So in general, when looking at sort of the introduction of maize or trying to figure out when maize arrived in the Southwest, the focus tends to be on single radiocarbon dates of just the earliest dates to try to establish the introduction of maize in the Southwest. Later early dates are often seen as uninformative, or that they have no value in trying to understand the introduction of maize. And I'll come back to this later of why that's not the case. But really early dates, such as Bat Cave in the 1980s, and one of the dates at Las Capas at like 4930 plus or minus 30 BP, are often considered outliers and are excluded from discussions of the introduction of maize. And so this focus on these single dates gives the appearance that maize was introduced around 2500 to 2100 BC, and that it spread rapidly throughout the various parts of the Southwest, and is often been associated that this rapid spread corresponded to sort of wetter environmental conditions. However, reliance on just these early dates really does not provide a complete picture for early maize use in the Southwest. So kind of going back to my dissertation a little bit. So one of the things that I was doing with these early pit house sites is when I was using Bayesian chronological modeling to look at the contemporaneity of pit structures at one of the early pit house sites, Mogollon Village, as well as using Bayesian analysis to redefine the pit house chronology in the Mogollon region, and wondered, could I take these same techniques and apply it to early maize in the Southwest? So what is Bayesian chronological modeling? Well, Bayesian analysis is really a statistical or probabilistic technique that was developed by Thomas Bayes in the 18th century. It was first used in archaeology as a way to sort of refine radiocarbon dates in the 1990s. It is pretty much a standard practice in the UK and has rapidly gained acceptance in the United States. Now, I'm not going to go into all the math and statistics behind the Bayesian approach, but just to say that Bayes' theorem, in sort of an archaeological nutshell, is that interpretive estimates equals dates times archaeological data and stratigraphy. So basically, it's a way to incorporate our existing archaeological knowledge to help further refine radiocarbon dates or other chronometric dates. And so why Bayesian analysis? Well, first off, a radiocarbon date, even though we actually call it a date, really is not exactly a date. It's an estimate of the radiocarbon content in a sample. And these radiocarbon ages therefore scatter around a true value, sort of, in accordance with some normally distributed quoted error. And this scatter is often made worse with the calibration process. Therefore, it can be really hard to discern what the true age of a sample is. And I want to show kind of an example of what I'm talking about here. So here I have 20 calibrated dates from 20 simulated radiocarbon measurements arranged from oldest to youngest. And this is often how we see maize dates being presented, either in a distribution graph like this or having the radiocarbon ages in a table. So date 1 is our oldest sample and date 20 is our youngest sample. And so as you can see, these distributions span quite a few hundred years, so it can be difficult to discern exactly what the age, the true age is. And one of the ways that archaeologists might approach this is to use visual estimation to kind of look at the distributions, maybe look for overlaps or some patterns in the data, and kind of eyeball when the age might actually be, the date might actually be. So if we look at the samples here, we might say that our date 1, our earliest date, dates to 20, or the oldest date, dates to 2280 to 2200 BC. Another approach is to focus on the median of the distribution range. And here we see the median for our oldest sample is 2170 BC. However, these dates are have been simulated from calendar dates that range from 2260 to 1880 BC and given an error range of plus or minus 50. The actual date of our oldest sample, date 1, is 2260. So the median was off by 100 years or so. The visual estimate was a little closer. But still, that visual estimate only provides an estimate for that particular sample. And it would be very unlikely, I mean, the probability of archaeologists actually getting or finding and then being able to date the very first maize cob that ever made its way into the Southwest is very slim. So Bayesian analysis allows you to not only provide date estimates for actual samples, but allows you to get for date estimates on archaeological events. And so what I'm using it here for is for the introduction of maize that don't necessarily have samples attached to them. And so using the same 20 dates that I've been showing in this example, if I put them in a simple Bayesian phase model, bounded phase model, we get an estimate for the start of these dates at 2410 to 2170 calibrated BC at a 95% probability. So that date incorporates our earliest date, but also provides estimates for what may have actually have come even earlier than that particular sample. So using a Bayesian framework, I set out to get formal estimates for the introduction of maize using Bayesian chronological modeling. I used tempo plots to estimate the pace of maize dispersal of early maize. And then I use kernel density estimation models, or KDE models, to look at the intensity of early maize use. And then using some existing paleoenvironmental reconstruction data sets, I compare sort of climatic conditions to the results from the pace of maize dispersal, as well as early maize use. Now, to do all these models, first I had to collect a database of maize dates. And scouring through countless journals, numerous CRM reports, talking to folks, asking for dates, I was able to compile a database of 896 radiocarbon dates directly on Maize macrobotanicals from 172 sites across the Southwest. And these are dates that date prior to AD 1000 on corn or on maize. So these dates are distributed across Arizona, Colorado, New Mexico, Utah, and northern Chihuahua and northern Sonora in Mexico. And then to create my models, I incorporate these dates from three different perspectives. One is using the EPA's level 3 ecoregions. One is using elevation type, lowlands, highlands, and midlands. And then because if you look at the distribution of the sites and dates within the different ecoregions, you see that some of these ecoregions, I have a lot of dates or a lot of sites, and some has very few. So I combined the ecoregions into four general regions with the upper northern, sort of the bluish tones, includes the Colorado Plateau and the Southern Rockies. The lower northern region, sort of shades of green, as the Arizona, New Mexico mountain and plateau regions. The southeastern region, sort of shades of orange, is the Chihuahuan Desert, Madrean Archipelago, and the Piedmont and Plains ecoregions. And then finally, the southwestern region is the Sonoran Desert ecoregion. And of these 896 dates, 5 were identified as outliers, and I'll come back to this in a second, and removed from the analysis. So all my models that I'm presenting here today are on 891 radiocarbon dates on maize from 172 sites. So how the models, sort of briefly, how the models were constructed. All sites that had 3 or more dates were modeled separately, just in a basic phase model for most of those sites. There were a few sites where if I had enough information to incorporate different components, such as an archaic and ceramic component or other stratigraphic information, that was incorporated into the model. All dates were given a 5% probability of being an outlier with a general outlier analysis. And this outlier analysis also proportionally weighs down any sample that is identified as an outlier. But if a sample was identified as an outlier, but the overall model had a good agreement, I left it in the sample. I left it in the model. If, however, it had a low, it was flagged as an outlier, but it caused the model to fail, essentially have a poor agreement, it was removed from the analysis. And as I said, 5 dates were removed from my analysis. And then my overall models were created by taking the start and end dates from my individual site models, as well as the radiocarbon dates from sites that had less than 3 dates. And this approach allows all the sites to be equally weighted. So Las Capas that has over 100 maize dates will be weighted the same as, say, the Powers site, which only has 2 radiocarbon dates. All of my models were constructed in OxCal 4.4 with the NCal 20 calibration curve. So to determine the estimates for the introduction of maize, I looked at it from 2 perspectives using my ecoregions and the elevation types. For both models, each ecoregion or elevation type was modeled as an independent, potentially overlapping phase, meaning they were all weighted equally and no implied order. And these two graphs show the overall structure of my two models, highlighting the start and end dates for each ecoregion or elevation type. So from the ecoregion model, here we see the list of the estimated start dates for or when maize arrived in each of the ecoregions, as well as a general estimate for when maize arrived into the Southwest. Based on the ecoregion model, maize arrived in the Southwest between 4605 and 3555 calibrated BC. Then to look at the elevation model, so taking the same dates, kind of looking from a different perspective, again, shows the start estimates for lowlands, highlands, and midlands, as well as an overall estimate for the Southwest. Now, this time, the model produced a longer date range with a much earlier starting date of 6385 to 3545 calibrated BC at a 95% probability level. However, this this is more of an unrealistic start, is likely due to the variable start estimates for the lowland, midlands, and highlands, and the tremendous gaps I have between those elevation types. So to take a closer look as to when maize first appeared in the different ecoregions, I constructed a probability matrix that calculates the probability that maize was introduced into one ecoregion prior to another. So basically, this table shows the probability that the maize was introduced to the region on the left-hand side prior to the region across the top. So you would read this as such that there is 100% probability that maize was first introduced to the Sonoran Desert prior to the Arizona, New Mexico mountains ecoregion. So using this probability matrix, say that the order of maize, sort of looking at the dispersal of maize, once it came in, first arrived in the Sonoran Desert, then to the Madrean Archipelago, then to the Arizona, New Mexico mountain and plateau ecoregions, the Piedmont Plains, the Chihuahuan Desert, the Southern Rockies, and then finally to the Colorado Plateau. So this order suggests a more sort of gradual spread of maize from south to north to east to far north. However, to really get a better sense for the pace of maize dispersal by region and elevation type, I use tempo plots. Now, tempo plots were created by sort of a statistical routine created by Thomas Dye. Again, won't go into all the details of the math, but it provides a cumulative estimate of the frequency of the start estimates. It pulls the raw data from the Bayesian models. So the slope of the plot sort of provides a visual measure for the pace of change. So where you see a really steep slope, it means that you had very rapid change. Where you see a more horizontal line, it means change or no change. If you have just a slight slope, it means that change was really slow. And looking at our region and elevation models, it appears that after the initial introduction of maize, the initial sort of spread or pace of dispersal of maize was a rather slow, gradual process. A shift to a fairly rapid dispersal really did not occur till about 1400 BC in the southeastern region, and as late as AD 100 in the upper northern and in the highlands or midlands region. Then I compared the results from the region, the tempo plots by region to existing paleoenvironmental data sets, ones by Gregory and Niles 2005 and Oliver and colleagues in 2019, specifically looking at periods of extended dry climate or drought, such as what had been defined by 1250 to 1000 BC or AD, like 158 to 173. And so we see in general that we have these steep slopes indicating more rapid spread of maize, roughly corresponding or either before or right at when we have periods of sort of extended dry spells or drought. So these models suggest that a rapid spread of maize may have occurred during sort of drier periods than wetter periods. And then I also looked at sort of the intensity of maize, early maize use with KDE models or kernel density estimation models. And this is a way, KDE models are a way to look at the distribution of radiocarbon dates to provide sort of really just a temporal or a means to look at temporal relationships and identify potential patterns in sort of chronological data. And we see again, looking at our KDE models, that there's considerable variability in the distribution of maize radiocarbon dates in the different regions. However, here I put the main KDE distributions on the same scale, so it makes them a little bit more comparable, as well as including in paleoenvironmental reconstruction data for precipitation, and temperature reconstructions. And we see like the orange, which is the southeastern region, the distribution of maize remains low basically throughout the entire Archaic to early, ceramic period. However, this is likely due to sample size. The southeastern region is the region that probably has the fewest, it does have the fewest radiocarbon dates. In the northern region, both the northern regions shown here in sort of green and turquoise, the distribution of maize, which is an indication for intensity of use, fluctuates sort of dramatically up and down over time. But we see in general that some increases in the distribution roughly corresponding to periods of dry environmental conditions. In the southwestern region, and that's the one shown here in yellow, the distribution of maize remains quite low until about 1400 BC, when we see a dramatic increase. And this increase is associated with a rise in temperatures and more variability in precipitation, as well as it also corresponds to the sort of introduction of irrigation canals, shown here, the blue line or bar in the Tucson Basin. But this increase in distribution really does not last and starts to decline around 700 BC. And so kind of looking sort of overall at the distribution of maize across all four regions based on these models, there does not appear to be a consistent sort of steady increase in maize distribution over time from the Archaic into the early ceramic period. And in general, maize usage seems to increase in intensity, sort of corresponding to sort of periods of warmer, drier, or more variable climate, whereas cooler, wetter periods are associated with decrease. And this does support the notion that maize was used as a risk buffering strategy and in the Archaic period, and maybe well into the early ceramic period. So, but I want to say these are just models. And as a famous statistician George Box once said, all models are wrong, but some are useful. And so these models should not be viewed as I'm saying that maize arrived in the Southwest and 4605 to 3555 BC. But more or less that they should be sort of a tool that we can use, to provide more objective means to evaluate radiocarbon dates or new dates on maize, to avoid issues like we've seen had in the past, like with the Bat Cave date, and some see with the Las Capas dates, that we can use these models to say if we get some early maize date that may not be in line with other dates we have much earlier, we can look at the models. Is it something that is even possible based on the data that we have? So it's a way to evaluate new dates. But these models also allow for the creation of more objective hypothesis for looking at the arrival of maize, the spread of maize, and the use of early maize that can then be used to compare to sort of data on the ground. And I also want to stress that these models are just preliminary, really need more dates. As I said, some of the ecoregions and areas are really sort of sparse dates. And trying to find additional radiocarbon dates has been a challenge. Now, I have been given, graciously, Robert Kelly has given me all the maize dates that were collected as part of their radiocarbon project that are now on the radiocarbon database. Unfortunately, the data collected for that database does not have all the information that I need to use those dates in my models. Therefore, I still have to track down all the original sources. So as I said, getting maize dates is a challenge. And it is also sort of compounded in some facts that I said, or some ways, due to the fact that later early maize dates are seen as uninformative, to the point that in going through some of the reports when I was looking for maize dates, I would find cases where archaeologists would say at archaic sites, oh, we had maize, but based on the other material culture of the site, it is unlikely that it's that early, so there's no point dating it. And I really want to stress that even these sort of what are seen as uninformative radiocarbon dates can be really informative to help us understand the arrival of maize in the Southwest. So to show this, I constructed a simulation experiment using the Madrean Archipelago ecoregion. So this is the actual data from my Madrean Archipelago ecoregion for the introduction of maize. The original model suggested that the introduction of maize occurred around 2720 to 1915 calibrated BC at a 95% probability level. Now, this has a really rather imprecise confidence interval span of 805 years. So for this experiment, I added simulated radiocarbon dates in batches of 10, 20, and 30 additional dates. And these simulated dates were added, distributed between 2205 BC and AD 1200. So we're not talking the earliest dates, which were the median values for my start and end estimates of this particular model. The simulated dates were given an error range of plus or minus 40 years, and each simulation model was run 10 times. So by adding just 10 dates distributed between 2205 BC and AD 1200 with an error range of 40, we have the potential to decrease that interval span to 530 years. And that's sort of the mean of the 10 models that of the confidence interval span for the 10 models that I ran. Adding 20 additional dates would reduce that span to 435 years. And 30 additional dates would reduce that span to 380 years. So these seemingly uninformative radiocarbon dates could really have the potential of providing more precise date estimates for the introduction of maize. So I really hope that this presentation demonstrates the utility of using Bayesian chronological modeling and other chronometric techniques to really kind of further increase our understanding of early maize in the Southwest, and that basically all radiocarbon dates on maize can be incredibly useful and add to our knowledge on this really important topic. Thank you.
Thank you so much, Dr. Love. Really fascinating presentation and unique approach. It looks like we have time for some questions. I'm gonna start with a couple that landed early on in the chat so they don't get lost. Could you tell us a little bit more about the contaminated bat cave sample? Somebody was curious about why it's older than the other samples and what the contaminant might be.
Well, the contaminant was that it was these were samples that were originally pulled out, I think, in the 60s, and and that they pulled from a collection and sent out for radiocarbon dating. And to preserve them at the time, they covered them in shellac to sort of protect them.
Yeah.
So in that shellac, the early date is, I mean, one, it is possible. We can see it's possible because, like, the date I got at SU is of the same age. There are other dates in the Mogollon Highlands that are also of the same age. Just at that particular time in the 1980s, that was the earliest date on maize that anybody has ever had. So it was, and the fact that it was new, but the fact that it had been covered with shellac raised all kinds of questions. Oh, well, it can't be a good date. But right. Unfortunately, that sort of, I say, stigmatized date, it stays that way, even though we have more recently dates of the exact same age in the same area. Interesting. But it stays, it has that reputation. It sort of gets a bad rap.
Right. Right. No, that's really interesting. Thank you. These things stick in our heads collectively, apparently.
Yes.
One of our viewers asks, why does it look like Midlands are slightly later than Highlands?
I don't know. Going back here. Oh, we go talking about date estimates, or let's see. Midlands. Highlands. It could also be sample size. That's one of my smaller ones. Yeah.
Right. Understood. Someone else asks, did your research uncover any regional differentiation of maize to specific sites, like blue corn?
No, because most of my going through something I was interested in, but it would mean really going into the weeds of all the reports and trying to get all the information. A lot of times that kind of data was not even collected at some of these sites. The metrics, you know, the type of maize that was submitted or what have you, it was maize, and sometimes that's all I have.
Right, right.
Unfortunately, that would be a really interesting topic, but not something that I was able to do with this research.
Okay. So here's an interesting question. Could you talk a bit about why the relative density of direct radiocarbon dates on maize lead to an accurate estimate of intensity of maize use across the Southwest?
It's just, I mean, it's supposed to be just sort of like a relative measure. It's a way to look for patterns. Like I said, it does not directly correspond to, I always tried to use distribution of maize and not so much intensity. I mean, it reflects intensity of use, but it's not a direct one-to-one comparison. Because like I said, these are models. It's a way to look for patterns in the data.
Right.
So when we have an increase in distribution, it likely relates to an increase in use. But like I said, they're models. So it could also be other factors, but it's a way to kind of look, especially when you're talking about large amounts of data, to look for those type of patterns that then can be further tested on the ground.
No, that's great. That's an excellent explanation. And I love your model quote about how some can be useful. And that's really a wonderful way of looking at it. One of our viewers asks, were you able to look at any samples from Chaco Canyon or Mesa Verde? Big areas that loom large in everyone's mind around here. So
yeah, I do have. Unfortunately, I don't remember. I mean, I have 172 sites.
Yeah.
I honestly Chaco Canyon.
No, you've got big data. We definitely.
Yeah, so I don't really focus. I mean, we could probably look at, I mean, all the sites are here listed. I have, and you can see that Colorado, that area is one of my lower. I don't have as many dates in that area.
Yeah.
Again, it's tracking down these radiocarbon dates is a tedious chore. Let's put it that way.
Yep. Yep. Absolutely. No, it's a worthy endeavor. And I'll slip in one of my questions because I hear our kind of along those lines. I hear some of our ethnobotanist folks muse about the botanical samples, corn, other samples undoubtedly in museum collections that could be looked at, right? Could be analyzed again, could benefit from new developments in radiocarbon dating, et cetera. Is that something that you've thought about for future work?
I mean, there's a lot of sites that I'm like, there's so much they dated, especially some of the stuff that was dated like in the 80s. And that there's more samples and we could get so much better dates today with a much smaller, tiny little sample. But of course that takes money.
No, of course, everything does, but it's good to know about the impact that such research could have if it were funded to really grow our understanding.
And this was, like I said, this was actually an aside to my dissertation, so there was no real actual funding for this particular project.
Yeah. No.
But yeah, no, tracking down, I would love, there's a lot of sites that I would love to date some more of the samples would be awesome.
I will pass that on to our ethnobot folks here. Let's see. Oh, so this is kind of a fun question, trying to pin people down. What someone asks, if you were pressed to give your personal best guess range of maize introduction dates, what would you say?
Well, I would still go with the estimate. I mean, it's a good estimate. It's based on the data we have. It fits, like I said, it will provide the dates that we do have and provide an estimate for what might have occurred earlier. So yeah, that 4600 could be possible.
Here's one that I don't know the answer to, of course. Asking about dates on are on macrofossils or microfossils, or are they on phytoliths or starch grains? Is that even possible to date that?
Well, those I don't know. All my dates are actually on maize macrobotanicals.
Amazing. Okay.
I did not use maize pollen samples, because a lot of times those pollen samples also include pollen from other species, other plants. Therefore, you're may not be getting a true estimate. So all of these radiocarbon dates are directly on some piece of maize.
Right, right. Uh, there is a question that came in the chat, and I'm not sure if this distinction is meaningful in your work, but they asked about the order of maize introduction by ecoregion based on species. Is there a difference? Would it be different if it was based on varieties, or is that a meaningful distinction?
That would be of interest, but like I said, most of when you go through a lot of these reports, I mean, if it tells me the part that was
Right.
if I get maize cupule, we're doing good.
Right.
Unfortunately, a lot of times, they were not formally identified, or there wasn't enough to make that type of distinction so that we would even have that data on a lot of these samples.
Right, right.
Although I said that would be a really interesting approach, but it would take, I think you would have to approach it from starting from scratch and kind of moving forward.
Right, right. And you didn't, so you mentioned that you didn't look at pollen, and we had someone ask, did the dates compare to pollen and pollen records in the region?
I didn't look at the pollen dates, because I said when I started going through looking at a lot of those pollen dates, a lot of those samples also include other things, so you don't really know what you're dating. So I don't know how that would compare.
I'm sort of curious. So one of the, I got a kick out of one of your charts early on, where you had the how the dates over the last 100 years, where people thought, right, the dates of introduction that different researchers thought throughout time. I thought that was a really fun chart. You could make that about a lot of different things, peopling of the New World, right, et cetera. But it was a really neat way to lay that out.
Quite a bit.
Yeah, no, I love that, right, to sort of show how what we were taught as canon at different points in school and students are taught really does evolve and change. And you mentioned that those, that was a hotly debated and controversial topic in this research. Could you speak a bit to kind of what were the politics in the discipline driving, some of that controversy? And
I some of it I don't know. Some of that predates me.
Right.
No, I think some of it was well, I know some of the shift from the 60s, the 1960s, when we had those really early dates, like about 3000 to the 1980s. It was the understanding of that old wood concept. And that the realization that because a lot of those, especially in the 60s, even if they had some radiocarbon dates, were actually done on wood, or maybe some of the corn cobs thrown in, and realizing that those dates are not an accurate reflection, because it includes old wood. And I think that was one of the big shifts from the 60s to the 80s, was realizing radiocarbon dating, also better understanding things like dates need to be whether they're like C3 or C4, it matters on fractionation and how they're measured. And
Right.
getting a better understanding of that really caused that shift.
Right. No, that's great. Excellent explanation. Thank you. Well, looks like we're right at 5 o'clock. Thank you so much,
Well,
Dr.
thank
Love. What a
you.
fantastic and data-rich presentation. It was really a pleasure to have you, and we hope someday you'll come up from Tucson and visit us and hang out with our ethnobot folks here at Crow Canyon.
That would be great.
All
Well,
right.
thank you. Thank you for having me.
Thank you. Have a wonderful evening, everyone. Thank you for joining us.